Good day, Bayas. Today, let's learn another relative examples and problems relating fluid mechanics and hydraulics. Today, let's have the Chapter 5 Fundamentals of Fluid Flow. In Fundamentals of Fluid Flow, we have discharge and flow rate and the continuity equation. In this problem, we are expected to have a discharge and we're going to use the continuity equation because we're dealing with incompressible flow of rate. For our problem, we have a pipe with 82 mm diameter moves water at a rate of 6.4 meter per second, while pipes with a 60 mm diameter and 75 diameter move water at a rate of 5 meter per second and 5.6 meter per second, respectively. A vent with a 60 mm diameter allows air to escape from the tank stop, and let's determine the velocities airflow through the vent and the dH over dt, assuming an incompressible flow. For our first task, we are tasked to calculate for the derivation of height over time and the velocity of airflow through the vent, assuming an incompressible flow. Bring out your pen and paper and together let's solve this problem. We have a diagram here, and the diagram shows an arrow that is entering the container and an arrow that is going out of our container. Those arrows are denoted as our discharge, denoted by the Q sub 1, 2, 3, up to 4. And we have also here capital letter D sub 1, 2, 3 to 4, which denotes as our diameter of the pipe. And the V1 to V4, that is the velocity of each of the pipe where the air or the water flows through. And also we have the diameter of the cylinder, that is 550 millimeters, and the height of the air inside the container, that is denoted as small letter h. For our given, we are given the following: the diameter of the first pipe 82 millimeters, its velocity 6.4 meter per second, the pipe's second diameter 60 millimeters, the third pipe millimeter 75, and the velocity of the second pipe 5 meter per second, the diameter of the fourth pipe 60 millimeters, and so on. Here, let us calculate for the derivation of height over time. Solution. For this problem, we're going to use this formula: Q in is equals to Q out. Q here is our discharge. So the discharge that is going in our container is equivalent to the discharge that goes out, where the Q here is also equivalent to pi over 4 d squared multiplied to the velocity. So plugging in all the given values to our formula. On our left side, let us plug in all the discharge that goes in our container. That is pi over 4, the diameter is 0.082 meters square, and the velocity, that is 6.4 meter per second. And on our right side, we're going to plug in all the summation of the discharge that goes out from our container. After plugging in all the needed values to our formula, we can now easily acquire our dH over dt, that is 0.1223 meter per second. That is the derivation variation of our height over time. Up next, let's move on. The velocity of airflow through the vent. Using the formula, discharge at 4th pipe is equivalent to the discharge of air. This is the pipe at the tank, at the top of the tank where air goes out. In solving for our fourth velocity of our fourth pipe, the unknown here is, of course, our velocity. And just plugging in all the needed values, especially the value we acquire from our dH over dt, we now acquire the velocity of the fourth pipe, that is 10.277 meter per second. The velocity of airflow through the vent. In conclusion, the speed of the airflow through the vent is 10.277 meter per second at 0.1223 meter per second dH over dt. Find out more of these problems in Fundamentals of Fluid Mechanics 3rd edition, the BSABE book, Problems 15-4. That's all for today, Bayaos. Thanks for watching. Up next, Chapter 6, Fluid Flow Measurement.